All right, last week we talked about arithmetic sequences and series, and we started talking about geometric sequences. Today we're going to finish up talking about geometric sequences and start talking about geometric series. So with a geometric sequence like the one I have here on the board, there's a common ratio. So we're multiplying by the same number to get to the next term in the sequence. Here we're multiplying by 2. 3 times 2 is 6. Times 2 is 12, times 2 is 24. So we said that our explicit formula is going to be a sub n is equal to our first term times that common ratio, which is 2, to the n minus 1 power. So there's our explicit formula for this sequence. Now let's talk about how to find a recursive formula. So a recursive formula for this same sequence, just like with arithmetic sequences, we're going to start off by saying what the first term is. So the first term here is 3. Then we're going to say that every other term, a sub n, is equal to the common ratio 2 times the previous term. So a sub n minus 1. So really all you need to know is the first term in the sequence and the common ratio between each of the numbers. In your explicit formula, the first term goes here, the common ratio goes here. In the your recursive formula, the first term goes here, the common ratio goes here. All right, so now let's talk about series, geometric series. So a geometric series is just a sum of a geometric sequence. So if we took, and instead of just listing these out like this, we're going to add them all together. All right, and so formula that we're going to use to find the sum of a finite geometric series. That is, if we're only summing this series, the first 6 terms of the series or something like that, we're stopping at some finite point. Then the sum is going to be s sub n is equal to the first term times 1 minus r to the nth power over 1 minus r. All right, so for example, if we wanted to find the first 6 terms of this series here, that's going to be the first term, which is 3, times 1 minus r, our common ratio we said was 2, to the nth power. We said we're trying to find the first 6 terms, so that's going to be our n. There's 6 terms in this sequence that we're trying to sum, or this series. And then 1 minus 2 down here on the bottom. And so 2 to the 6th power is 64. So this is going to be 3 times 1 minus 64 over negative 1. So that's negative 63, but divided by 1, that's positive 63. Times 3 is going to be 189. So the sum of the first 6 terms of this series is going to be 189. And we can check that. Since 6 is not too hard for us to check. With 3 plus 6 is 9, plus 12 is 21, plus 24 is 45. The next term would be 48, plus 48 is 93. The next term would be 96. So plus 96 is going to be 189. All right, so this checks out. So this is the formula right here that we're going to use to sum geometric series. Now, there's another formula, but we really don't need that formula to do this week's homework, and so I'm just gonna leave it off for right now. And this is the formula that we're going to use. So let's do a couple of examples. So let's say we've got 1/2 plus 1/2 to the 2nd power plus 1/2 to the 3rd power plus all the way up to 1/2 to the 8th power. So we're summing up all of the terms in this series. And so the formula we're going to use is the sum is equal to the first term times 1 minus r to the n over 1 minus r. And in this case, the first term is 1/2, and r is 1/2. That's the ratio, and they've kind of broken it down for us in this example. They've just given us this is r, what's inside the parentheses here. So r minus 1 minus 1/2 to the nth power. So how many terms are there that we're trying to add up? Well, we can see here that this is 1/2 to the first, to the second, to the third, all the way up to the 8th. So that's going to be 8 terms. So this is 1/2 to the 8th power. And that's over 1 minus r, which is 1/2. All right, so this is going to be 1/2 times 1/2 to the 8th power. Well, 2 to the 8th power is 256, so 1/2 to the 8th power is going to be 1 over 256. And 1 minus 1/2 is 1/2. And we can see here we're multiplying by 1/2 and dividing by 1/2, so those are going to cancel. And we're left with just 1 minus 1 over 256, which is going to be 255 over 256. So that would be our answer for this first example. All right, the second example asks us to find this sum here. So this uses sigma notation. We use this capital letter sigma here, and just like with arithmetic series, this means the sum from the first term up to the 9th term of this series. So remember our formula, S sub n equals the first term times 1 minus r to the n over 1 minus r. And now, so what we need to do for this one is first we need to figure out what that first term is going to be. So if we plugged in 1 for k here, we get 3 times -4 to the first power. So -4 to the first power is -4 times 3 is -12. So our first term is -12. And then we can see that the r is here, and our n is going to be 9 because we've got 9 terms from the first term up to the 9th term. So we've got 1 minus -4 to the 9th power divided by 1 minus -4. So let's just write that as 1 plus 4. All right, so I'm going to need a calculator for this. So we get -4 to the 9th power we know is going to be negative. So it's going to be -12 times 1 plus whatever we get here. So -4 to the 9th is 262,144. And then 1 plus 4 is 5. And then, so if we add 262,144 plus 1 is 262,145 divided by 5 and then multiplied by -12. We get that this is equal to -629,148. So that's going to be the answer for example number 2.